All right, so we on our tests a lot of times have questions that use the word not. And on the test it might not be capitalized and bolded. So we do need to be looking for that word not and be able to recognize it and apply it to the problem. Sometimes I tell students to put a true and a false next to each one. And if you get two falses, you need to look at those again. But if you only get one false, then that's your answer to your not question. Let's look at A. True or false? Point C is the intersection of AC and BD. Line AC and line BD. We learned yesterday in one of our postulates that if two lines intersect, they intersect in exactly one point. So in this case, they intersect at point C. That is the intersection, the one and only. So that one is true. Alrighty, let's look at B. Coplanar points B, C, and E lie in plane F. Let's check them one at a time. Is B in plane F? Check. Is C in plane F? We're looking good. And is E in plane F? All of those are in plane F, making them coplanar. Therefore, we've got another true. All right, next one. Point E lies in plane FBC. I see a huge no-no here. What is the big deal about C? They named that plane wrong. Completely wrong. That is not supported by the diagram. Point E lies in plane... There is no such thing as plane FBC. Because remember, to name a plane, you have two choices. You can write the word plane and then do an italicized capital letter. Or you can name 3 points in the plane. F is not a point in the plane. F is the name of the plane, but it's not a point in the plane. So that is not supported by the diagram because F is not a capital letter with a little dot by it. It's not a point. So therefore, C is definitely false. Points A and D are collinear. Now, I realize that in the diagram, they do not have a line drawn. But you really don't need a diagram to answer letter D. Any 2 points, we learned this yesterday a little bit, any 2 points in the universe are collinear. So you really don't need a diagram. Just because the line isn't drawn doesn't mean it doesn't exist. That line does exist whether or not it's drawn. And so A and D are collinear whether or not the line is drawn. The diagram does support it because it has point A, it has point D, and we could put a line through it. Collinear means I could draw a line through it. All right. We're going to talk about the postulates we learned yesterday, but we're going to talk about them out of order. That's why this says number 2. So we learned yesterday that when 2 lines intersect, we get a what? Point. When 2 lines intersect, they intersect in exactly 1 point. At the intersection of 2 lines is a point. So that's one of the postulates. You're like, hey, Miss Anton, that's common sense. And I'm like, yeah, it is common sense. You get a point when 2 lines intersect. All right. Another postulate that we learned was when 2 planes intersect, they intersect in exactly 1... Dun, 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 you got it, line. What do you get when 2 planes intersect? You get a line. So when 2 lines intersect, you get a point, and when 2 planes intersect, you get a line. Good. How many points determine a line? How many points determine a line? I'll give you a hint. Just think about how we name a line. Normally, we name a line with 2 points from that line, and that happens to be the correct answer. It takes 2 points to determine a line. Let me show you how I taught it. If I only have 1 point, let's name it Z. I only have 1 point. How many lines pass through that point? Well, this one, and this one, and this one, and this one. An infinite number of lines pass through that point. One point does not determine a line. But then, if I undo all of that, let's see. Okay? But then, if I have 2 points, oops, let's pretend Miss Tanton can draw a straight line today. Could you draw a different line than I drew through Z and Y? Could you draw another line? No. Through 2 points, there is a unique line. There's only one. That line, it has a name. Its name is ZY. And there is no other line that could pass through both Z and Y except that one right there. So how many points does it take to make a line? It takes 2 points to make a line. Takes 2. All right. In that case, how many points does it take to determine a plane? This is easy. You just go up 1. You go from 2 to 3. Now, it's 3 with a little asterisk by it. What does that mean when something has an asterisk? At the bottom, it's like, see the note below, right? 3 points determine a plane. But here's the deal. Think of you have a tripod. Tripod has 3 legs. A tripod is named a tripod because of geometry. It's because 3 points determine a plane, and actually 3 legs on something is the most stable you can get. 3 legs, like if I had to sit in a chair, honestly, that would be the most stable chair. And we'll talk about why in a second. 3 is the most stable you can get. But if you took that tripod and you lined the legs of the tripod up in a row, what would happen to that tripod? It would fall over. So yes, 3 points determine a plane, but they have to be non-collinear points. And to remember that, just think, hey, if I lined up the legs of a tripod in a row, it would literally fall over. So they need to be non-collinear. They need to be spread out. They need to be spread out. So 2 points determine a line, 3 points determine a plane, as long as they're non-collinear. The reason I was saying chair 3 is more stable than chair 4, because all it takes in chair 4 is for one of those legs to be a centimeter shorter than the others, and then what would that chair feel like to sit in? It'd be one of those chairs that wobbles. Have you ever sat in a wobbly chair? Doesn't it bug you? It totally bugs me. Tilty. Yep, that's right. So actually, 3 is the most stable. 3 points determine a plane. Sometimes 3 of those legs will be coplanar. They'll be touching the ground, and then that 4th leg won't be touching the ground, and it's non-coplanar with the others. All right. So, all right, looking at the homework, let's look at 2C. Use the figure to state whether each of the following is true or false. These are the ones I was asked about. Okay. A, B, C, and F are coplanar. Coplanar means same plane. So are points A, B, C, and F in the same plane? No. Points A, B, and C lie, I'm going to call this plane R just to make it easier. A, B, and C determine plane R. We're now locked into plane R. That's the plane we're in. That's the lunch table we're sitting at. And then we're full. Student F comes along, we're like, sorry, you can't sit with us. Our table's full. You're over on that table over there. You're not in our plane. You're not sitting at our lunch table. Point F is non-coplanar. It is not in plane R. So this one is false. Non-coplanar. All right, next one. B, C, D, and E. Here's where things get interesting. You would think, oh, I'm just going to answer this one just like letter C, but you're not, because there's a difference here. Tell me the difference. Good, Tin. Look at points B, C, and D. Look at them. They're not spread out. They don't determine plane R. They are lined up in a row, like ducks in a row. They are collinear. So here's the deal. Coplanar means I could put a plane through them. I could put a plane through them. Try again. Look again, Chisholm. It's definitely true. If it says false on the answer sheet, then I need to change it. It's definitely true. Okay, so here's my plane. Here's my plane. Isn't that pretty, Miss Stanton? Here's B, C, and D. They're all on this line. There they are. There's B, C, and D. Then I've got point E, and it's up here. Could I put a flat surface through this skewer and the tip of my finger? Absolutely. Look at this. Boom. I caught B, C, D, and I caught E up in the air because these are intersecting just like that. So I'll draw it on here. Could I draw a plane? Yes, I could. Let me just draw one right now. I have B, C, D, and I've captured E. These are coplanar. True. Next one, letter E. For letter E, I don't need a picture. I don't need a picture. I'm going to write true because guess what? Any 3 points in the universe are coplanar. Just like any 2 points are collinear, any 3 points are coplanar. I can connect any 3 points in the universe with a flat surface. I can connect the tip of my finger with a point on Saturn's moon with a point in China. I could connect all 3 of those points, no matter how far apart they are, with a flat surface. It'll have to go through some things. It'll have to evade walls and stuff, but yeah. So point E and F are in the same plane. Yeah. Any two points are in the same plane. Okay, and G, part G, A, B, C, F. Remember, once you name A, B, C, you're locked in. They're spread out. They're a tripod. You're now locked into plane R. They are in plane R. Hey, you guys, the plane I just named R. You're in plane R, but F, you're not in plane R. So it is true. Those are non-coplanar. Those 4 points are not in the same plane. 3 of those are, but the 4 points aren't. All right, 3C. Use the figure at the right to name the following. All lines that are parallel to plane JFAE. So you find the plane, you highlight it. If this prism was sitting on a flat surface, then this plane would be a vertical plane. So every line that's also vertical are the lines that are parallel to JFAE. Any other line that is also vertical, going straight up and down, going in the same direction. CL, DH, GB. All 3 of those lines will never intersect the blue plane, and they're coplanar. They're going in the same direction. You can look at your vocab sheet. I think it says you can name a plane with 3 or more letters. You can name a plane with 6 letters if you want. So it's just 3 is the minimum. So an example would be CL. 4C. Name the intersection of the pair of planes. All right, there's 4 postulates. One of them said when 2 planes intersect, they intersect in exactly 1 line. Very good. So your answer to all of these should be a line. Should be some sort of line. You have to name it. Should be some sort of line. So if we're looking at this one, UXR. You need to be able to visualize what plane that is. That's not a triangle. Don't draw a triangle, although triangles can represent planes. What I recommend is you draw more like a parallelogram. U to X, okay, I'm going to go R to S, and then I'm going to connect them. This plane is shooting diagonally through my prism. That's cool. I like it. VWS, VWS. All right, that plane represents the right side of my prism. So you're trying to find where they overlap. Where do those planes meet? Where do they overlap? What points do they have in common? Those are the things that you're asking yourself. And where they meet, dun, 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 he has a name. The name is RS or SR. All right, let's look at 5C. You need to state whether the following... Okay, so we're going to look at these points. And first, we're going to decide if they're collinear. Next, we're going to decide if they're coplanar. So I'm going to write that over here. We're going to put a little checkbox. Here we go. All right. Points A, C, and D. A, C, and D. Collinear means could I put a line through those? Nope, I sure couldn't. So they are not collinear. And then coplanar means could I put a plane through them? Well, yeah. There we go. But guess what, guys? I said this earlier. Any 3 points are coplanar. So I didn't even need to look at a picture to determine if those were coplanar. Any 3 points are coplanar. So no matter what, they were coplanar. I didn't need a picture. So I would choose the one that says collinear, non-collinear, and coplanar. All right, G. B, C, E, and F. B, C, E, and F. Those are definitely not collinear. I couldn't put a straight line through them, a line. Are they coplanar? Oh yeah, definitely. Look at this. See that plane? It's going from the back top to the front bottom. That is a nice flat surface. I didn't need to curve to go catch the fourth point. No, I can't put a plane through anything. No. I'll find one that aren't coplanar. So this one is A again. And H. J, H, and F. Same answer again. These are not collinear. Is that okay with everyone about not collinear? But they are coplanar because any 3 points are coplanar. It does not look collinear, guys, because this is 3D. This is a, see the dotted lines? This is a prism. This is a prism. So J is up here and H and F are down here. I can't put a straight line through that. You've got to visualize this as being 3D. This line is hanging out way below J. Here's that line, here's HF, and J is way up here, guys. So no, don't try to put a line through it. It's 3D. Okay, so yes, let's summarize. No matter what, 3 points are coplanar. You said, can you put a plane through anything? You can put a plane through any 3 points. So show me, Miss Stanton, when could I not put a plane through it? Let's talk about it. 1, 2, 3, 4. This time, I'm going to shade in the plane that contains F, H, and E. Okay, here we go. They are all in this plane. We're locked into a plane. Because I have 3 points, we're locked in. Now can I go grab J? No, I can't go grab J without curving my plane, which planes are not allowed to do. So what I would do every time is I would check the first 3 points. I would shade in the plane for the first 3 points, and then either see if the last point is in the plane or not in the plane. Were they invited to the lunch table or not invited to the lunch table? So, C, D, G. All right, I'm locked into a plane. Here's my plane. No other plane in the universe goes through all 3 of those points. And then H. Aw, H, you weren't invited to the party. You're not in the plane. A plane is not always a rectangle. It doesn't have edges because it goes on forever. Well, I can't, it's hard, it's not 3D. It goes on forever. We just represent it with rectangles, parallelograms, pentagons, all sorts of flat shapes.